Good evening, ladies and gentlemen, that we are here to here for the second lecture organized by the History and Heritage Forum of IESL. Today, that is on probing unresolved mysteries of ancient water technology by an eminent scholar in this field, Dr. P.B. Dharmasena. Dr. Dharmasena has obtained his BSc Bachelor's in Science in Physics in Science in 1971 from University of Peradeniya, and obtained Masters in Agricultural Engineering in 1982, and then PG Diploma in Soil Science from Norway, and PhD in Geography from University of Peradeniya. He is a researcher for more than 30 years on soil and water management. That his area covers various aspects such as small tank hydrology, soil erosion and conservation, watershed management, small scale farming, indigenous knowledge, etc. And also he has worked in the Department of Agriculture and universities of Sri Lanka and various UN and other organizations. At present, he works as a visiting lecturer at Rajarata University and also works as a consultant for IUCN. With this brief note, I would like to invite Dr. P.B. Dharmasena to start his presentation on probing unresolved mysteries of ancient water technology. Over to you, Dr. Dharmasena.
Thank you, Professor Navagamma, for the great introduction. Good evening to all of you. Now, today we are going to start another discussion after some time. This is not a new one, but I have been doing for some time with Dr. Kamal Laksiri, who initiated this History and Heritage Forum. I cannot forget leaving him without thanking. This particular topic, probing unresolved mysteries of ancient water technology. I am going to cover a few points. One is the present crisis of water in Sri Lanka. Then ancient master plan of water resource management, especially had in the Rajarat area. Then Anuradhapura Kingdom, water-based city planning, how they really developed this particular ancient city based on groundwater. That is one of these mysteries. Then rainwater harvesting, again back to Pidurangala. I think Kamal can remember that we have been there and we had a very good time with some engineers and families. Then I will move to tank cascade systems, the first agricultural heritage in Sri Lanka. Then finally, traditional tank village ecosystem. Lessons for future evergreen agro-ecosystem concept. The concept is there to reduce the carbon emission, carbon dioxide emission. And we are going to have this concept in future so that how we can get rid of the greenhouse gas emission in Sri Lankan context. Present prices of water. If you go through these points, you will be able to understand that sometimes it is not because of that it is impossible, but it is difficult, and we have sometimes neglected the reason for this one. The first one is high discharge to sea, was in drought and flood while wasting productive water. You know, we have losing more than 50% of annual incidents to sea. Then seawater intrusion, especially in Mena and Jaffna, because of sometime high extraction of groundwater. Ignorance of the ancient water resource management systems, I should say, because of these past development activities, we have not considered well the ancient water resource management plans and systems. Then next on, less attention paid on restoration of tank cascade ecosystems, because we can understand that this particular system is unique to Sri Lanka. That kind of perfect vision they had in the past. Then the other problem we have here, lack of effective coordination among water-related agencies. There are 40 agencies at present dealing with water in one way or another. Finally, lack of a national water policy. We have submitted a cabinet, we have submitted the national water policy draft to Sri Lankan government in January 2021, but so far we have not get any kind of response. So those are the real crisis of water at the moment. If you're going to analyze this one, you may know all this, but I'll just say that we have 103 river basins and 80 major reservoirs and dams, small tanks, 16,000 plus, small anchors, 14,000 plus. If you just calculate annual average rainfall as 2,000 millimeter, just multiply by the land extent, you will get about 131 billion cubic meter. Unfortunately, out of this, more than 50% is wasted, drain into sea. That is our most difficult part to solve. And if you just go through this particular table, I just extracted from a long table, long list. Here, if you take drainage to sea, you will see here 34%, 13%, 12%, and in some cases 62%, 77%. If you just go through the absorption points in the drainage basin, if you have a very low percentage of water wastage into sea, you will get more absorption points here. But here, you don't get any observation point except these 3 minor tanks in Ganga. And also, we are experiencing flood here. Okay. And coming to the main point, our water management system in ASEAN Sri Lanka is multi-purpose and multifunctional. Some people have the view that this water resources management system in Sri Lanka in the past is meant for irrigation alone. No, there are a lot of other functions it had. For human needs, settlement, drinking water, bathing, recreation, other domestic needs. Then they have attempted rainwater harvesting systems. And also they loved environment. They wanted to ensure the existence of the environment, flora, fauna, and other environment. Then the mystery that we are talking about is one city planning. They have built up cities, Anuradhapura, Sigiriya, based on water. Then parks, landscaping, water springs, ponds. Then also in the past, they had some administrative boundaries based on water. And also they have had a lot of bitter experience, and they wanted to come up with some strategies for natural disaster mitigation, flood, drought, cyclone, and epidemics. If you see this ancient master plan of water resource management, specifically for river basins like Daduruwe, Kalawe, Mallatwe, and Yangwe, and even at country level, inter-river basin level, inter-reservoir level, from one reservoir to the other, sub-watershed level, I mean here especially cascade systems, then village level and field level. I don't think that we can discuss all, but that is the plan that they had in the past. If I spend some time to talk about the history. Prince Vijaya invaded our country during 543-505 BC. Those days, sailors from different countries, they have entered the country from Alirani Harbor for trading. This is Alirani Harbor here. And we are close to Murunkan. Then Vijay also came along western coastal border using northeast monsoonal winds. But he purposely passed Alirani Harbor to Kudiramale, earlier we call Tamanna. There were 10 regional kings, including the Princess Queen, ruled the country at the time. Princess Vijay killed most of them. Prince Vijay killed most of them with the support of Princess Queen. That was the end of 10 kingdoms in Sri Lanka. What are these 10 kingdoms? Now, according to Vargapurnika and the source is Manavi Vimalratna Thero, I located this on this particular map, but unfortunately, we could not trace the evenness of these kingdoms. One is Kevesasta, northern part, then Kavasthala, Rakungiri, Pulangiri, Indra, Agni, all around Mahagiri, Dumaka, Kadira, Chalaka, and Nilagiri. But once I put it on the drainage basin map, then I found that a lot of these kingdoms are on the top of these water states, especially on a rock or mountain. Kevesasta, northern part, most probably we can suspect that it might have been on Madukanda, Kavasthala Yangwaya on Sigiriya, Rakongiri Ritigala to cover Malatoya, Upulangiri, Dambulla to cover Kalawaya. Indra, we could not trace, but it is to cover Maduroya, Mundanyaru, and Galloya. Then the Agni, most probably somewhere here, Namanukula, it covers Kumbukangwaya, Maniganga, Kirindiwaya. The biggest kingdom here, Mahagiri, Samanal mountain area, Kalani, Kalu, Walave, and Mahavali. Then for Deduroya, they said Duma Kadira kingdom, Chalaka kingdom, Miyoya, and Nilagiri, Modarga Maru. These local kings must have placed kingdoms on mountains to protect the major river basins. If you look at this map, you can see about 7 points, and yellow colors are the Yodala giant canals connecting from one point to the other. For example, here, Dambuluya to Malatoya, then from Malatoya to Kanadarava, and Nuvarava to Mahakanadara, then from Yogodala to Nachadu. Likewise, we have some old canals to find its way to fulfill the requirements of reservoirs or the adjoining river basin. Now, take the example of Kalava-Tisava Giant Canal. We found that some specific characters. One is it is single bank canal. It runs along contour, almost contour. This is the contour, and it follows the contour, something somewhat parallel. Then water is collected from upstream, like here. Then water is released to both sides, here, and also it feeds a lot of cascades downstream. Canal moves along tank upstream, you can see here, and tank cascade systems are fed. Now, if you look at these canals, those are moving around, keeping two types of water depressions. One is tank, the other one is they call Diakali. Now, this particular one in 1970s, they have shortened the Yodala, that's in red, to get water quickly from one place to the other. After some time, he made a confession from an irrigation published in Economic Review, April, May 2010. He says, inconvenient truth behind engineering designs of irrigation projects developed during the last century. He mentioned there as, those days we thought that the canal was planned to avoid rock barriers, as the ancient people did not own the technology to break them. That is what they felt at that time. Later on, they realized. But this rock they have used sometime as Diakali, just to keep some water here with turbulence. And this is kind of sediment trap. When it is moving like this, this is a Diakali, and this is the place for another tank. Tank and Diakali is the combination they are using to store water during dry period. They can utilize this tank and Diakali to feed the downstream areas. Here they have two. One is at Mahiluppallama, just taking this through natural rock to make Diakali here, or soil mound to make a Diakali here. And the beauty of this system is that this is a low landscape. They put Diakali here and the other part here. And from Diakali, they have some sluices to feed this tank. This is Samanukole River. Then the same way here, Alut River. Then they have lower sluice cases to feed the water to downstream area. Here also they have some sluices to feed downstream area, so that both are there to feed downstream whenever they need during dry period. So this is the one of the technology that we could be able to come. One Dr. Ashok Karunaratne did his PhD on this. The comparison between Diakali and Weber, placed above the canal, Weber placed below the canal. Canal has been connected to the Diakali. In case of Weber, constructed the canal running above the Weber. So it will cover all this sediment inflow coming into Weber, so that those tanks have not been sedimented. Then Diakali has been connected to a natural rock line or soil ridge. One of the Weber has been raised to a higher contour to store water. Issue of water through a natural process. Here, release of water to Weber is through sluice placed on the left bank of Yodala Canal. And this is meant for controlling sediment. Here, controlling the sediment and providing water to paddy tract. Providing water to upland cultivation by Diakali, combined with human settlement and cascade systems. So those are the differences that we can find between Diakali and Weber, but both of them are really water reservoirs. And if you go to these earlier Yodala canals, you can find one well-known canal from Kala Weber to Tisa Weber, then from Yodala to Nachadu, then Nachadu to Nora Weber. You know, this place is our ancient city Anuradhapura. So it is fed by these giant canals from reservoirs, and there are reservoirs like Nora Weber, Tisa Weber, Basawakpulama, and so on. So coming to this mystery of Stargate, we have a lot of Stargates around the world, but this is something just plan-like thing. You can see here central part, and you can see here showing the symbols of aquatic areas, aquatic fish, and sometimes some other features. So there are some other symbols here. We will see what stands for this. Now, if you think that it could be the city plan of ancient Anuradhapura kingdom, the king can come here with some advices and think about what they are going to develop within the city. This is from Ranmasuyan. And these are the top 10 stargates in the world. According to that, we can think that those structures have not been identified well. Here you can see some structures like and some gates, some mysteries like this, boxes and all, and here the Stargate in Sri Lanka. So there are differences as far as the Stargates are concerned. Not always symbolic maps or sometimes structures. This is from England. It's from Bolivia. And this is Peru. So if you just put together, this is the Stargate in Ranmasuyan, and it has 4 gates here into the powerful place where sometimes the palace is there, must be. Then there are some symbols like this. It's like this Abhegiri complex. And this is the city. And also there are symbols like this. Now, according to Manaya Vimal Ratnathero, he thinks that these are Yaksa Aksara. Before this Brahma Aksara came into scene in Sri Lanka, this symbol says represents an area well exposed to sunlight, planned for settlements, gardens, etc. So these are the things. It seems to be not only a plan, but also a land use plan in the city. And here, this water cordon, after some time, after planning, we had Bulankulama facing to inner city, then Basavakulama facing here, then Tisarava again facing here, Nuvarava facing there. So they wanted to have a kind of groundwater reserve to be built up within the city. So this is the inner city, and you can find here these reservoirs. This water culture in Anuradhapura kingdom, we found that this water cordon around the kingdom include Tisava, Nuvarava, Basavakulama, and Bulankulama. All these are focused to enrich groundwater in the kingdom. Then if you just look at the paddy land extent under these tanks are not like in the other tanks in Sri Lanka, these are relatively low. Catchments are not adequate. Because of that, they had to take water from adjoining river basin. For example, Giant Canal coming from Kalaway Basin. Then you know that if there is any kind of stream, natural stream, like Mallatoya and Halpanoya, there should be a wide strip of alluvial soil. Alluvial soil means it's sandy soil. So sandy face is there within the city. How these gigantic structures could be sustained on this valley, on this alluvial face. Hard bedrock to trap groundwater. When you see the geologic map, granitic gneiss and Charnockite gneiss are dominant in that, like this. Here granitic gneiss, here and here. This is Charnockite gneisses, here and here. And here you get this granitic gneiss hard rock. Here, this part is sandwiched with these two. So it's a good opportunity for water to get trapped there and pressurized. These are the comparison between granite and cyanocite. Cyanocite is also granite, but it has orthopyroxene, magnesium silicate and iron silicate. And here we don't have any orthopyroxene, so that this is so hard, and this is with this one and mica. So that this is a bit unstable compared to granite. And also when you just go around Anuradhapura city, you will find ponds, you will find these water gardens around palaces. Then you will find wells like this and some ponds in different shapes. And one beauty of this is always it consists of steps. Although it's not meant for to move down, but there are steps. So one can imagine that these are the levels that we can monitor from time to time, whether the ground node table is moving down or coming up. So that there's a very intensive monitoring system if you just go through all these wells and ponds. World situation is too bad. World sinking cities are there. So many cities you can see. But if you take just Mexico City here, Bangkok, Thailand here, Beijing, China, Tokyo, Japan, and Manila, Philippines. Here you can see what is the rate of these subsidence. Beijing in China by 11 centimeter per year, Mexico by 28 centimeter per year, Jakarta by 28 centimeter per year, Bangkok by 12 centimeter a year. But anyway, now these governments have taken steps to minimize this subsidence. You can see what's happening in these cities and even these buildings. When you take the consequences of this subsidence, there may be cracks like this, crack formation, right? Scientists found that the reasons are for the subsidence. One is weight of the buildings like this for towns and urban cities. Then maybe groundwater depletion or shifting of tectonic plates. And coming to our city, we have in Ruwanelisa vertical cracks like this. Jetavanarame, 4 cracks they found here like this, and even vertical cracks in Tisamarame. Most probably due to groundwater depletion. In other places, there may be some other problems. Weight of buildings also a factor for this crack formation. So we had a very good opportunity with some engineers and their families to visit Sigiri and Pidurangala. I said expedition, right? So we had a good time to learn a lot of things. We spent one day climbing Sigiri. The second day we climbed to Pidurangala. And we have observed a lot of this conveyance, water conveyance, this vertical. And also we found that water springs still there And also, if you go to internet and you can find these are in active positions in some place just after rain. Here you can see those are coming up. But do you think that this is the height of these sprints? Because it must be at least 10-15 feet to get a good, nice look there in the park. So what we thought that these two rocks are here, Sigiriakins must have been in need of clean drinking water. So they must have found something here. And we found 3 water conveyance systems. One is open water conveyance canals, brickworks, sealed subsurface clay pipes like this between Sigiri and Pidurangala. Then sealed subterranean conveyance canal, stone, 1 foot, 1 foot, 1 foot. So it's a kind of tunnel. So they must have had some kind of mechanism to convey this water here and there to make a network of canals. If you go to this Sigiri from western entrance, there are 3 types of gardens. Water garden 1 here, water garden 2 here, and water garden 3 either side of this. In these gardens, you can find in one place, octagonal pond. In Sinhala, we call Atapattam Pokuna. This Atapattam Pokuna, if you take this one here, and the elevation difference here and there is about 126 meters. It's too big, too high. And we could be able to trace one path like this along ridge and coming smoothly here without dropping like this. So it's about distance is about 1,612. And if you look at this Atapattam Pokuna octagonal pond here, fountain ponds here in the water garden 2. And some people believe that this water might have come from Sigiriya tank, but it is Sigiriya tank and the fountain garden is almost at the same elevation. But octagonal pond and head difference between these fountain ponds and octagonal ponds about 26 feet, which is more than enough to make a good water spring. And this is the octagonal pond. How they got this water into this pond, no one knows. That is the mystery at the moment we have to resolve. What do you think about this Pidurangala rock? Is it natural? You can see a good shape here. It's a funnel-like shape. This part is convex and this part is concave. And some stone pieces, big pieces of rock we found at the bottom of this Sigiriya. And these are the natural decay lines, but we found the cracks are vertical. So it must be due to huge explosion and it's not a natural decay. And also you can find when you go there, there's a small kind of ridge-like things here around the boundary, and the water will come and get fallen here and here. So it can be a rainwater collecting area. And you can see some man-made cuts here to direct water to the this side, where you get all these other miracles. And you will find some waterways like this, not direct, but in some places like this. And also there are canals, very distinct canals, cannot be natural because if it is natural, the decay will take place like this. But here you get cuts. And there are some cascading type to filter water. You know that when you need water to be mixed with air, you have to have this kind of things, or water springs. Here you can get more and more depressions like this to trap any kind of impurities which is coming along with water. So filtering process is taking place there. And the last one is here. The last one, you will get all these sediments left here, and finally you will get water from this tunnel. Sorry, funnel. This is the last one. Water filtering ponds. And finally, you will get from this point, and like this, after this, no evidence to show where it goes. And also there's another one we call the balancing stone. When you take the surface of this is concave and this convex, the other way. The mirror image of this Pidurangala rock, it's like a mirror image. Our ancestors, they had the practice that they wanted to have a mold first and see how it looks like and go to the big job. Here you can see the same shape with rock surface and this mold. So some mold to prepare the rainwater harvesting model. It is the mirror image of the flow pitch. And okay, finally, the platform area of Pidurangala rock is about 2 hectares. If it is assumed that 80% of monthly rainfall could be collected for the safe side, from this flow pitch, the volume which could be stored monthly is 10,000 cubic meters for the whole year. 10,000 cubic meters. This water can be collected from this system. What does it mean? This historical perception can be rejected as a myth, yes. However, this system, if rehabilitated, will supply annual water storage about 10,000 cubic meters to the people who are living around and are threatened with the chronic renal disease with unknown etiology. So that is the practical use of making this curious way of investigating this old ancient water technology. And even if you go to any day on this, you will find this water. This becoming active as it was in the past. Okay, next one. If you take this all map with 150-meter contour, then you will find a lot of our old reservoirs are just hanging. Here you can see, except few like Giant's Tank and Tisaveva. So this means they must have had some kind of mathematical approach, but we don't know how it has come to reality. This is Anuradhapura district. You can see that the network of streams and tanks, small tanks. This is Yangwe, this is Mallatwe, and this is Kalawe. So if you have this kind of network of water canals and this water absorption points, I don't think that we have to expect any kind of flood or any drought. But now this is not working in that proper way which we had in the past. The technical main factors to form this kind of network, one is morphology, low elevation, moderate undulation, then rainfall biomodality 1,500 millimeter per year, Soil and geology, regular aquifers, low infiltration, and reddish brown earth and low humic clay. So this is the combination of factors that led to form this kind of cascades and streams and tanks. That is why we say that one thing that this is very unique to Sri Lanka, because all these factors should be together. The other one is that if you have more rainfall, you will not find that kind of intensive network. If you have low rainfall, less than 1,500, even then you don't have that particular network. So this is kind of silver line of isohydrate we have here in Sri Lanka, where you get all these cascade systems. So cascades, that's a cluster of tanks organized well to make a good environment to ensure the sustainability of the system. Professor Madhum Bhandari in 1985, he has defined the cascade is a connected series of tanks organized within a microcatchment or mesocatchment later of the dry zone landscape, storing, conveying, and utilizing water from an ephemeral rivulet. Now, if you find this cluster of tanks here anywhere in Sri Lanka, but remember, all these tanks are not meant for irrigation. Now, these tanks, Kuluweva, is there in the wild to serve the purpose of drinking water or others of the wild animals. Then Olagamweva, we don't have a village, but tank and the paddy field. So there are some storage tanks. Whenever you need water to the downstream major tank, it can be released here and it will come here. So there are different tank systems in this cluster. So that is why we need a cluster, because it serves different purposes. And when you see the ecology of this particular system, we found a lot of things. So we wanted to come up with ecology-based definition also later. Tank cascade is an ecosystem where water and land resources are organized within the microcatchments of the dry zone landscape, providing basic needs to human, floral and faunal communities through water, soil, air and vegetation with human intervention, but on sustainable basis. If you take these clusters, the same factors here, but you can see here northern and north central part, northwestern part and southern part, three different zones. And the cascades are like this. Water movement is concentrating back to another big tank. So the boundary of this is here, we call one cascade. Here there's another cascade, here there's another cascade. So these cascades are sometimes in existence as complexes. We call this Kallanche tank cascade complex. Like that, here we have Tirapani cascade, Mahakanamulla cascade, Ulagal cascade as a complex. And we had another opportunity to make a proposal to declare that cascade systems as globally important agricultural heritage system in Sri Lanka. We found a lot of ancient technology when we were moving around. And finally, in 2019, Food and Agriculture Organization declared village tank cascade system as the first globally important agriculture on 19th April 2009 in Sri Lanka. It is the first in Sri Lanka, but the 39th in the world. And now, because you know the climate change is taking place, and the most main reason is that the imbalance of this carbon emitted to atmosphere and absorbed here to the vegetation. So that we had to have some kind of concept we call evergreen agroecosystem concept. If you go through all these cultivation of crops as a mixture, leaving zero fallow, seasonal, semi-perennial, and perennial together as a mixture. Then so many green manure plants. In the past, in traditional farming system, we can find it around fence. Shade management they have done even in China lands because they have left some big trees and pruned some trees under which they have done this farming. And that's a mixed cropping system. So these are somewhat similar to traditional agriculture. So that is why we wanted to talk about traditional technology, because cognizance can be taken from this traditional technology to even very new concepts. So I just want to make it a bit fast. Now, lessons for future evergreen agroecosystem concept. You can see here, century place in this Bombay, that's for women and kids. This land is utilized by men. So that all these things come in here and decomposed and serves as fertility source to paddy tract. So that is no kind of waste things coming up from this system. And also this is crystal clear water because of Godawal is to trap water. Is soil rich to control erosion. Then here the Kattakadu downstream reservation to filter all these impurities here before it enters into the paddy tract. So many things are there to look after. And finally, what I want to tell you that even here, right here, now we are talking about agro-silvopastoral systems. But if you look at this very carefully, agro-silvopastoral system, the oldest one you can find from Sri Lanka, from this particular traditional village tank ecosystem. You can see Gaskoman and Tawula free roaming area for cattle. Here, China has agro-silvopastoral system. Whenever it is fallow lands, it can be grazed by cattle. Then here, this Bombay free roaming and land improved. We can improve this one. So silvopastoral system and even paddy fields you can use for grazing during fallow period. So this is the system that we had in the past, and whatever the name comes up, there's an answer for this. Even for drought, flood, then high winds, and even epidemics. This is solution for all these natural disasters. But what I think that no one can go and investigate alone for this mysterious concepts. So we'll have to get all these together as a multidisciplinary team is required to probe the unresolved mysteries of air and water technology. For example, archaeology should be there, history should be there, hydrology should be there, architecture and geology and anthropology. If you do it alone, it's like a blind man is touching the elephant and say, this looks like leg, looks like ear or something like that, the whole system. But to study the whole system, we should have some kind of collection, not an isolated approach. So mysteries of ancient world technology should be studied, should be resolved by sitting together, hydrologist, architect, geologist, anthropologist, then archaeologist. So thank you very much for spending some time to enjoy, and this quite interesting presentation, I suppose. Thank you very much.
Yeah, thank you, Dr. Dharmasen. I think it is kind of an very interesting presentation. I hope that we have some questions from the audience. You can even use the chat box and you can raise hands, then we can respond to those questions. Yeah, Dr. Laksiri, you can comment on the presentation and the content.
I am waiting for Dr. Kamal Laksiri.
Yeah, he's there. Yeah, he's there.
Yes, Kamal. Dr. Kamal?
Yeah, I think he's, yeah, he has not pointed.
Yes,
Dr.
I have joined with him, and the most interesting one for me was the Pidurangal, actually. So I was lucky to go with him and visit the place, and we inspected all these features he mentioned here. So I think it's a very interesting thing. And I think can you all hear me?
Yes, we can hear. Yeah.
Yes, please go ahead.
Yeah, there's a message come. Yeah. So as you said, actually, it's all of us, engineers, archaeologists, historians, we all need to get together and to resolve these mysteries. So it is one of the objectives of our forum. So I can see lots of the members are here. So it's time to discuss further. Yes.
Yes. Thank you. Yes, we have one raise hand, Dr. Dulini. Can you please raise your points, Dr. Dulini?
Yes, thank you very much. I think Dr. Dharmasena did a really nice presentation on explaining what kind of explaining really nice aspects of our history, archaeology, and engineering. But what I'm interested to know is what kind of research are currently being done on cascade systems, and are there any numerical modeling that is being done on these kind of cascade systems at the moment in Sri Lanka?
Yes, if you just contact Professor Vasanta from engineering faculty, he has done a water budgeting in Yangway, where you get a lot of cascades. That is the recent publication he has. And we have some more projects, like the one is where I work, IUCN, that is managing together. So it's a combination of forest, agriculture, and tourism, so that we can have a lot of kind of information generated. And also there is another one, Healthy Landscape Project, JEF project, and it's there, one implemented by SACET, funded by Biocity, and it's another wealth of information now we are having, so that some publications are there, and even in Faculty of Agriculture, University of Peradeniya, Professor Pushpa Kumar and Professor Deepika, they have done a head project for cascades, Mahakanamulla cascade, and they have generated a lot of information, so that just from even internet, you can find a lot of things. Thank you very much, Dr. Dulini.
Yeah, thank you very much. I will actually contact the people that you have mentioned and get more information. Thank you very much.
You're welcome.
Thank you, Dr. Dulini, for your comments. Then we have another raise hand, Praki.
Yes, thank you very much. It was a very interesting the explanation of the cascading system. I, being a national tour guide, I explain these things to our tourists. Now, one thing I want to know is there are two matters. Just give me a second. I want to reduce the volume of my TV, which was on. Okay. One thing is, according to Dr. Dharmasena, is that plain surface of Pidurangal, is it a carved thing, artificially carved by people? That is a number one question. Number two question is, now this, when we go to Pidurangala, they say there's a cave entrance where Mughal had entered and come through to Sigiriya underground. That cave entrance can be seen on top of the temple, but it is blocked, they say. Anything known about that cave entrance, or that whether it was something to do with this irrigation system, doctor? And then again, that last thing that I want to state is, maybe the elephant of Kashyapa is supposed to have gone to a mud place, and Madatugama is a place where they have been having clay in the manufacturing thing. So it may be related, but the surface of the Pidurangala and this cave entrance is what I'm interested in, to getting to know if Dr. Dharmasena knows about anything. Thank you.
Yes, Dr. Praki, first question, it's a very good shape for rainwater harvesting systems. So even natural, even man-made, it's a good way of collecting rainwater. That is one. But if you we have been there and we found that not natural rock outcrops, but boulders. We had some sharp cuts, and we found that cracks are formed vertically, perpendicular to the natural decay system. So it really leads us to think about that can be an explosion. So we don't know how it happened, but there are good technologies here in the past to work with stones. That is first question. The second one is the tunnel. You talked about tunnel, right? It's now closed. So no one knows what happened there, but there are some myths and stories. I don't know much about that. You talked about another one. What is that third one, Dr. Pratt?
No, there's an area called Madatugama, no? Maybe.
Yes. Now there are two stories. One is Madatugama. The other one is just Habaran area. Wherever that they had this fight with elephants. The elephant wanted to avoid some muddy lands, and elephant has turned, and people thought that that is the end of the war, and they have been defeated and they have ran away. So that Kashyapa was alone, and he was injured by one of these Mughalans' weapon. So that Kashyapa came to one of these rocks there near to Habaran, and he found that he could show that Sigiri just on his vision. So he wanted to say that people, he said the people surrounded by him, and he wanted to have his grave there on the top of this particular stone. We went there and we found that still that grave is there. One brickwork with the grave.
You are referring to near the village, Habaran village hotel up there as a hill, exactly. I think. No, yeah, that's exactly. Yeah. And this also the other thing. If I'm not disturbing you, the Paramitana, when Professor Paramitana, they had found some inside the rock also, Sigiri rock also, there had been some carving, and there's a story that there's a blind person still living. I think he has said that doctor has sealed that off with concrete. Any idea about it? I don't think it may be a mythical story, but if that is so, then I mean the carving, when you look at Sigiriya, the stone carving trade was there, and they would have been able to do something like that interior of the Sigiriya rock, whether there's any evidence of anything was there.
I also came to know about this story, but that particular man who said that is no longer alive, and he died. And he said to so many people who worked with Dr. Paranavitana, and I don't know much about this because no evidence. to show that except the place that they marked with some kind of differences compared to the natural rock. So that is there, only that evidence is there at the moment.
Thank you very much, Doctor. It was very interesting, the cascading system and but the planning of
Yeah,
cities at that time. Thank you very much. And it was a very interesting conversation and educational program for us. Thank you.
Yeah,
Thank you,
thank
Doctor.
you. And then we have another raised hand by Engineer Major Nisanka. Yes. Yes.
Thank you.
Major. Yeah.
Thank you. It's very interesting, and for me, it's valuable. And if I tell it like, I was convinced the value of this forum. So I am so grateful for the organizers. Dr. Dharmasena, I was trying to buy the particular book. I contacted IESL also. I don't know who will answer me. I'm interested to buy this book, but I failed to buy it. Can you please tell me how can I buy it?
What is that book, please?
This is 2010, Dr. Dharmasena.
That is economic review.
And this, I will get that name. One second. Yeah, that is one book. Other one I will tell you. Yes. The book that launched Water Engineer, Memories of a Water Engineer.
Kamal,
Hello?
can you?
Memories of a Water Engineer. I don't know. I think this IESL, I don't know, Dr. Navagamu, whether you can help me.
Dr. Kamal?
Engineer Vasu, I think, recently, we had this book launch also. I think I will arrange you to our water forum. Actually, they organized it.
Dr. Kamal, can I answer?
Please. Yeah, she's the one. Yeah.
I think I can coordinate with the water forum chairperson and let you know. But how can I coordinate the whom you want?
I can make this communication with.
Okay,
Nisanka.
Okay, we'll do that way.
Thank you very much.
Thank you, Engineer Kamala.
Okay.
Okay. I think we had. I was just searching for Gil. Are you there?
Sorry.
Yeah, no. I was trying to connect to Dr. Gill from UK. She was there. He had also commented. Right? Now there are some.
Dr. Diello Mendes, I want to hear your voice. Dr. Diello Mendes.
Right,
No,
I think, yes. Okay, any other questions from the audience? I think it was an interesting one. No, okay, Prakir, another raise hand.
Okay,
yes,
just I want to suggest,
yes.
Doctor, this as this sort of thing is very interesting. Now, as national tour guides, we as a company tourists all over these places, and it is very educative. Now, this group that we can see how many people are there. There are more than 67 people. Doctor, in your case,
No, we had 80 plus.
Yeah, anyway, what I'm saying is now this sort of people, now all of them are interested in this, doctor. So why not arrange some sort of tours to just maybe one day, it's difficult, but some sort of a tour to educate not only us, the others who are interested, to show what it is actually in some case. If it is possible, sort of a excursion every 2 months or 3 months due to lack of funds also, we have to think about that. Now, anyway, just an idea about an excursion, so that possibly.
Thank you. Actually, we have to share the cost. The participants have to share the cost. We that is in our cards, but the problem was we had kind of this diesel, that fuel issue. That's why we did not organize these things. Right? We will organize it.
Thank you very much. We will
yeah, we
definitely
should,
contribute, and thank you, Doctor. Thank you.
Yeah, the recording of Dr. Gill's presentation is there, right? So that we will share it with others. Any other questions? Yeah. Any other questions? And then, right. So I would like to invite Dr. Samanthi, our secretary, to propose the vote of thanks. Dr. Samanthi.
Yes, sir. Thank you. Good evening, everyone. First of all, many thanks for Dr. Dharmasena. It's a very great presentation and very informative presentation. I would like to thank our IESL President-elect, Engineer Dr. Kamal Laksiri, for initiating this webinar series and also arranging this webinar through his communication. So through his communication, actually, we had a great presenter today. So we know that Dr. Dharmasena's contribution to the field is immense, and we as engineers learn a lot, and we are inspired by our own engineering heritage. I would also like to thank our chairman of the History and Heritage Forum, Professor Udeni Navagamua, for your great support and guidance in organizing this event. Also, I would like to thank Engineer Janaka Priyantha, who prepared this flyer nicely and timely manner, so that we could get a great audience for this webinar. Also, I would like to thank the IESL from the IESL side, Mr. Tamila Priyantha, and the IESL staff for making necessary arrangement to publicize this webinar and facilitating conducting this webinar via Zoom. So we had a very good audience, and it is actually a multidisciplinary team of professionals, engineers, architects. Actually, what in our History and Heritage Forum, we expect you all. And in future also we are conducting similar webinars. So we invite all of you to join with us and learn our own engineering heritage. So thank you very much for this great presentation. Have a great evening to all of you.
Yeah, with this note, thank you very much for your participation. Dr. Dharmasena, thank you very much for volunteering. And with this note that we would like to conclude the meeting, and we'll meet again when we organize the next presentation. Right. So we will invite you all to the next presentation also. Thank you very much. So
Thank you. Thank you. Good night.
Good night.